Hello, this is Luke Avedon. Today I wanted to talk about using SQLite with C. So I've been learning C to teach myself more low-level things because I'm a web developer by day, and this is more interesting. So I noticed using lots of command line applications, very popular to just use JSON as a database or YAML files and text files, and that's cool. But nothing is cooler than a real database, especially SQLite, the most popular database there is. And it's just a file on your hard drive, and you can do SQL-y things, your joins and everything, and it's amazing and beautiful. And it's super easy to use with C, my new favorite programming language. So in this tutorial, if you will, I'm using just GCC on Windows through MinGW. And where is my terminal? I'm also using DB Browser for SQLite, which I already have installed. So I'm not going to talk about installing those two things. You can just download this one here, and for the compiler, I just use Chocolatey, which is like the less good package manager for Windows compared to Linux, but it's all good. So let's make a little folder for our amazing project. We're just gonna make a command line app to add things to the database and just do a simple select. But this is a fun getting started because once you have this, you can do whatever you want in the database. So we're going to compile SQLite, download the C program for SQLite, the source code in one file, the amalgamation, apparently it is called, then make that as a static library so it's inside our program, which is much bigger than a dynamic library where a program says, hey, look for SQLite on the system and just use that. No, we don't want to do that. We're just going to make it huge bloatware and put the whole database inside our program. So you can give the command line program to your colleague and you don't have to be like, oh, is SQLite installed, dependencies and all that, which I'm pretty traumatized from Node when it comes to dependencies and things. So I want to get as far away from that as possible in my life. So we're going to make it static library style. So just going into this new empty folder, we're going to go back to the SQLite website and download all the code for SQLite. In download, let's download the amalgamation, the entire thing. I'm just putting this in downloads. Cool. Now, going back to our terminal, if I go to my downloads folder, and I've never bothered to change on this computer the user to my name, it's just user's user. I'm going to expand what we downloaded, SQLite amalgamation 34.5 gazillion, destination path, our wonderful project. Okay, now I'm going to just go back. C2 SQLite. Cool. Now we have this folder we extracted. Aha, so it's all in this one huge C file, all of SQLite. We're going to compile this into a little library. It's a big boy. Anyway, Jesus. Okay, stop that. YouTube is yelling at me in the background. Okay. I guess I never use Chrome, and I did for this, and I subscribe to notifications of videos. That's really annoying. Okay, so we're going to compile that C file. So just GCC flag C, which means, hey, make an object file. So turn this into machine code, but not an executable yet, because we're going to do something with that object file. So here we go. It's compiling. I'm going to close Chrome so I don't get any more notifications. Use Brave. Okay. This is boring. So this is going to compile all SQLite into an object file. And then we're going to take the header, SQLite3.h, and copy that into our main directory too. Of course, we could also just, whenever we compile from whatever directory we want, we can say, hey, our header file is in another directory with the I flag, I think. But it's good to move it where it needs to be. Okay, so we have correctly made yay our object file. So now let's turn that into an archive called, so AR is the archiver, and then the flags are insert R, the files, or replace them in the library, create it if it doesn't exist, and add an index to the library, which I believe only just increases the performance. Now, the next thing we have to do is we have to say what it's called. I guess tradition is that starts with lib. And I know when you tell GCC where the library is, you would do like L SQLite3, and that's matching a file that starts with the word lib, I believe. So we'll uphold that tradition, lib SQLite3.a. .a is going to say this is a static library, as opposed to .so. And then this is the object file that we just made, feeding into this. Okay. Aha, now we have our amazing library file. I have a fancy microphone, but it's really far away, so I don't know how this is going to sound. Now let's move this library file to where we are going to do our neat work. And now I'm also going to go ahead and copy the header file. Just for convenience. So here we have everything we need to put SQLite into our application and compile it all as one executable. So now I'm just going to create our C file that we're going to start working in. I'm going to call it SQL. I'm going to use Vim for this one. So the first thing is I'm going to include the header file for SQLite. And I'm also going to just include standard input output, and that's all we need for now. No, go away. Okay, and then I'm going to make a simple main function. Now we have a pointer to what will be our database, where our database is that we can use, and a string for messages. The error message is coming back. So RC is going to represent the result code. Were we successful or not doing our database stuff? Now here's from the library, SQLite3 open. All you have to do is give it a file, a name of the database, because unlike SQL Server, where we're connecting to a server and passing messages back and forth, all SQLite is a file on our computer, which is so cool. And at the memory location of our database, if something horrible has happened, then just print out an error, standard error, that we cannot open the database. In format string SQLite 3 error message db. Now let's close, because we're all done, the database, and now return 1 for sadness. Okay. Now, well, that's embarrassing. Okay. We're going to create a table in our database. So, like writing dynamic SQL in SQL Server, all we're doing is we just write a string for SQL, pass it to our newly compiled library, and it executes that and does whatever database stuff we want to do. So we're going to just create a really simple table called friends. It's got a primary key, auto increments with its ID, and then it just stores our friend's name. And even if we don't have any friends, that's okay. It's just an example. Now we're going to get that result code. Is it happy or sad? Execute. Here's now when we pass to the library, we say, hey, execute this SQLite command. We just got to tell it, this is the database we're working with. Here's the string of SQL commands we want to pass. Don't remember what those do. And then error message. Other arguments which we will probably use later. I'm going to do kind of sloppy, but another if something goes wrong, print a message. I'm going to be so sad if I record all this and the audio is terrible. SQL error. This is really more recording to my future self the next time I want to do this, that I found a way to do it that I like. Now, here I'm actually going to free the memory of the error message, which seems like, okay, we didn't do that before, but we're actually getting an error message back from SQLite, so might as well. And now I'm going to close the database and return sadness. But assuming nothing went wrong, we still have to close the database and then return happiness, 0. Okay. I think that's all I want to do now. Let's see if this actually compiles. So I could go back into PowerShell or just in Vim, the bang character, just like you're at the terminal. So this is just as if I went back to PowerShell, typing it in. So we want to compile. We're going to specify SQL.exe. I'm sure that's a name that would never confuse anyone. And then this is the name of our source file. And we're also including our new library that has the lib prefix, libsqlite3.a. See if this works. Okay, that looks good. Now I'm going to try to run it from inside Vim still. Okay. Now I'm going to try to see if there is a database to open in DB browser. Open database. Here is the test DB that we just made because we just ran this program. Okay, and here's our friends table, and it's empty. So let's go ahead and just add code to make it insert data. So instead of just inserting data here in main, what we're going to do is there is a callback function that SQLite library will return to us and say, hey, we did update these rows, we did not update these rows, and this is the way we get messages back from the database. So we're going to define that up here, and we pass arguments just like when we pass arguments to main, argc, and then a pointer to a pointer of the actual argument value. Then there's pointers to the column name, return happiness, yay. Here's our callback function. Now let's make another function to insert the data. SQLite 3, and we're just going to pass a pointer to the database as a parameter. Now I'm expecting horrible things to happen, so I'm going to set up an error message here. Char pointer error message style string. Now let's just create the SQL. What could be easier to insert values? Insert into friends. Name values. We'll say Tom. Okay. Now we're going to try to actually call the database, pass it this argument like we did to create the table, and record the result code. DB. Aha! That's what goes in this argument, the callback that we made. But what does this one do? I don't remember. And error message. And if something goes wrong, just like elsewhere, print the error. SQL error. Format. Error message. Return 1. Now the problem with getting this error message is realizing we did not clean up the memory used by the error message. So SQLite has the SQLite free function, just as we use down here. So we are going to do that. We're going to free the error message since we're done displaying it. Now, assuming nothing goes wrong, we're going to return 0. All right. Now let's compile and run. Same thing. I guess I could just do up. Uh-oh. I made a boo-boo. That doesn't make sense. Okay. And I spelled this wrong too. Everything's SQLite 3. Now I'm actually expecting this not to work because we did not do if not exists. Yes. Okay, so create table, friends already exists, as we have here. So for now, we're just going to change that to if not exists using our normal SQL skills. And we're not actually calling the function we just made. So I'm going to put that into insert data db. Gonna try again. Compiles SQL.exe. Okay. Now, if I refresh this database, will I see Tom? I do. That is exciting. Okay, now let's make this a little less lame and actually take command line arguments of select data or insert data. Or what are we going to insert? So we're going to use some more strings, so I'm just going to import string h so we can do string compare. Okay, I'm going to add, we're going to take arguments. How many arguments? Just the normal standard stuff. Pointer to an array of argument values. And I think trying to think if we should we want down here if someone passes flag S, then we can select data. We'll make a select table function, which we don't have yet. And then we'll do a similar thing for insert later on. So let's go make our select table function, and these have to be above main. Just threw me for a loop when I was learning, and SQL loop. Okay, select table, char, error message, just like all the others. We're just going to do select star from friends. Now return code and just execute our SQL. The database, the SQL we're passing, the optional callback, mystery, whatever this 0 is, and error message. We'll do yet another if not okay. Standard error, SQL error. There's a problem with the SQL. Error message. We're done with the error message. You are freed. Return 1. Now return 0. Okay. So what we can do is, how is the database giving us the rows that we just asked for? It's sending it back to us through the callback. So all we have to do is expand our callback that we have here and actually print back what SQLite is sending us. So I'm going to do a really basic for loop. And print the column and the value being sent back. So just as we call our main with argument values, SQLite calls this callback with argument values and also column names. So we're just going to go ahead and print those. So 2 variables will be printed. The first one will be the column name. The second one will be the value. Now, if something is, that value is null, we're not going to just leave it. We're going to explicitly print null using fancy pants ternary operator. Now, when we're all done, just finish it off. Line and okay. So if we recompile again, that's good. SQL just calling should, if I removed, I'm going to remove this just insert data at all times. But if I just call the program, we don't see anything because we didn't give it a -s. So this hopefully will show something. Aha! Tom, because we called it again and we had that always insert. And if we look in our database, we've now done it 3 times and we have Tom 3 times. And there it is. Huh. That's not good. I thought I had not inserted anything. Had this called. Does that mean I don't understand something and we'll have to re-record this video? I think I just had not recompiled it and it was still calling that insert function. Because now we're good. Okay. Let's actually make it so we can pass what we want to insert. So just like this, if you pass I instead, so we want it I and then another argument of the name that we're going to insert for this example. So if they don't pass I and then also the name, if you just pass I, it should yell at you. So we'll say usage specific I name. Write a name. Return unhappy. But yeah, so if they only pass I, x equal 2, they're not having a name, we would expect 3. Now call our insert data. But as you can see, we are still going to have to modify this to actually pass the name. Okay. Now let's change. Instead of just getting the database, the pointer to the database, we're going to get the name. I'm going to delete this static SQL, which always inserts Tom, and instead insert into friends name. We're going to first format this string. Actually, let's first just set aside space for it. 256 bytes. Then create the dynamic SQL with a variable. We're going to use library function sprint f. SQL insert into friends, just like before, name values. Okay. Now, this should work. Just double checking. I did change it, so we are passing in the name. Let's recompile. Okay, so let's see if I just do I by itself, it should yell at me. Yes, put in a name. I, muffin, I think I can put it in quotes. Muffin cat. Do we see muffin cat? If we select, that is the actual name of my cat. Okay, it worked. That's amazing. Insert Luke. That's my name. And there we are. And what's much better is we can use this database not just from the command line or in C. We can use it in so many ways and do whatever we want to the data of 10 people named Tom, a muffin cat, and Luke. So I hope this was like a new video, but I hope maybe one person in the world found it helpful, and I will definitely be coming back to this video for myself when I forget how to do this. Okay, thank you so much.